settle into the sleepy mind channel. Tonight, we are traveling through a great span of our planet's history, from the final moments of the dinosaurs to the world outside your window today. This is the Cenozoic, an era that has shaped familiar landscapes, great mammals, and living ecosystems across the Earth. Together, we will wander through ancient forests, endless grasslands, rising mountain ranges, frozen plains, and quiet seas as we explore 100 fascinating facts about the age of mammals. So settle in, get comfortable, and allow the distant past to unfold gently, one peaceful discovery at a time. If you enjoy relaxing journeys through history, science, and the natural world, please take a moment to like the video and subscribe to the channel. It is a wonderful way to support future sleep stories like this one. For all night listening, visit the playlist where you will find more peaceful journeys designed to help you relax, unwind, and gently fall asleep while learning. Before our journey begins, it helps to understand what the Cenozoic is. About 66 million years ago, life on Earth reached one of the greatest turning points in its history. An enormous asteroid struck the planet, ending the reign of the non-avian dinosaurs and countless other forms of life. Forests burned, darkness spread across the skies, temperatures changed dramatically, and established food chains collapsed. Entire families of animals vanished, but life endured and entered a new era. Scientists divide Earth's history into immense spans called eras, each lasting many millions of years. The era following the extinction of the dinosaurs is the Cenozoic. Its name comes from ancient Greek words meaning recent life, although 66 million years hardly feels recent. In the immense history of our planet, the Cenozoic is the latest era, and it continues today. Every modern forest, beach, bird, and mammal exists within this same period of geological time. The Cenozoic is often called the Age of Mammals, and for very good reason. Many were no bigger than squirrels or rats. They searched for insects beneath fallen leaves, climbed trees beneath the cover of darkness, or hurried through thick undergrowth while giant dinosaurs dominated nearly every landscape. For a very long time, mammals were survivors rather than rulers, adapting to a world that belonged to someone else. With the great dinosaurs gone, however, countless ecological opportunities suddenly appeared. Forests no longer echoed with the footsteps of towering herbivores. Rivers, plains, mountains, and coastlines offered habitats that had become unexpectedly empty. Evolution, which never truly stops, slowly began exploring new possibilities. Over millions upon millions of years, mammals diversified into forms that would have seemed impossible to their tiny ancestors. Some grew enormous tusks, others developed powerful claws. Some became graceful runners, capable of crossing endless grasslands. One remarkable lineage abandoned life on land altogether, returning to the oceans until its descendants became the largest animals ever known to have lived on Earth. The Age of Mammals was never simply about mammals becoming larger. Great mountain ranges continued rising toward the skies. Oceans altered their currents. Forests expanded and retreated as climates shifted. Vast grasslands spread across continents that had once been covered in woodland. Geology and biology became partners in one extraordinarily long conversation that still continues today. One of the most fascinating things about the Cenozoic is its incredible variety. Unlike the age of the dinosaurs, which many people imagine as a single continuous world of giant reptiles, The Cenozoic contains many different worlds. Some periods were so warm that palm trees flourished in places where snow now falls each winter. Crocodiles swam through regions that today spend much of the year locked beneath ice. At other times, enormous glaciers stretched across continents, while woolly mammoths and shaggy rhinoceroses wandered wind-swept grasslands beneath cold northern skies. The climates changed, the continents drifted, the animals evolved. Yet through every transformation, life continued adapting with astonishing creativity. As we travel through this immense span of time together, you will meet creatures that seem almost imaginary. There were mammals with strange horned skulls, unlike anything alive today. Ancient relatives of elephants carried tusks that curved in surprising directions. Horses began as small woodland animals with several toes, before gradually becoming the swift runners we know today. Even whales, the giants of the modern oceans, began their story as mammals walking across dry land. Deep time has a way of turning patience into wonder. That idea makes the Cenozoic especially comforting to think about. In our own lives, we often measure time in hours, days, or years. Even a decade can feel like a very long time. Yet the story we begin tonight stretches across tens of millions of years. Against such an immense backdrop, the hurried pace of everyday life becomes wonderfully small. There is nowhere to rush. Our journey will unfold as gently as geological time itself. We will wander through ancient forests warmed by climates unlike our own. Stand beside quiet rivers where unfamiliar mammals come down to drink. Watch the first whales venture into shallow coastal waters. Follow herds across endless grasslands, and eventually step onto the frozen plains where mammoths leave their great rounded footprints in fresh snow. At the beginning of the Cenozoic, the Earth looked both familiar and strangely different from the planet we know today. The continents had already begun taking on recognizable shapes, but they had not yet reached their present positions. The Atlantic Ocean continued widening by only a few centimeters each year, a movement so slow that no animal could possibly notice it. Yet over millions of years, those tiny changes transformed the map of the world. India was still slowly drifting north towards Asia. Australia had only recently begun separating from Antarctica, and South America remained isolated for much of this time, allowing many unusual animals to evolve without outside competition. Great mountain ranges were still growing, coastlines rested in unfamiliar places, and vast stretches of land looked very different from the landscapes we know today. Although the asteroid impact had caused one of the greatest disasters in Earth's history, the planet itself never stopped changing. In the years immediately following the impact, enormous amounts of dust and ash remained suspended in the atmosphere, reducing the amount of sunlight that reached the surface. Many plants struggled to survive under these darker skies, and as vegetation disappeared, the animals that depended upon it also declined. Predators soon followed, leaving entire ecosystems broken apart. Yet even during these difficult years, life refused to disappear completely. Seeds remained hidden beneath the soil, protected until conditions improved. Ferns spread rapidly across damaged landscapes and became some of the first plants to reclaim the land. Insects survived in sheltered places, while birds and small mammals searched for whatever food they could find. Recovery did not happen quickly, but little by little the living world began rebuilding itself. One of the reasons mammals survived this period better than many larger animals was because of their size. Most mammals were small enough to shelter inside burrows, hollow trees, or narrow cracks among rocks. They required less food than giant reptiles, and many reproduced more quickly, allowing their populations to recover sooner once conditions became favorable again. Long before the extinction of the dinosaurs, these mammals had already learned to live cautiously. Many ventured out only at night, using darkness as protection from predators. Others remained hidden beneath thick vegetation, where they could quietly search for insects, seeds, fruit, or leaves. The behaviors that had once helped them avoid becoming another dinosaur's meal suddenly became valuable advantages in a world where survival depended upon flexibility. The first few million years of the Cenozoic were marked by slow and steady change rather than sudden transformation. Every generation inherited tiny variations from the one before it. A slightly stronger jaw allowed one animal to eat foods that others could not. A longer leg made another just a little faster when escaping danger. Better hearing, sharper eyesight, or a more efficient way of finding food might improve the chances of surviving long enough to raise offspring. None of these differences would have seemed remarkable within a single lifetime. Yet over hundreds of thousands, and eventually millions of years, those small advantages gradually accumulated, producing entirely new species perfectly suited to changing environments. As life recovered, forests spread across enormous portions of the planet. During much of the early Cenozoic, Earth was considerably warmer than it is today. In places where snow and ice dominate today, dense forests once flourished beneath mild skies. Towering trees formed thick canopies overhead, while vines climbed towards the sunlight and broad leaves collected warm rain throughout the year. Flowering plants continued expanding into new habitats, providing food for insects, birds, reptiles, and the growing variety of mammals. Every fallen tree slowly became home to fungi, insects, and countless microscopic organisms, each playing a quiet role in returning nutrients to the soil. Even in death, every part of the forest contributed to the growth of new life. Many of the mammals living within these forests would seem unfamiliar to us today. Some belong to branches of evolution that disappeared long ago without leaving any living descendants. Others represented the earliest ancestors of groups that still exist across the world. At first glance, they appeared rather ordinary. Most were modest in size, with bodies adapted for climbing, digging, or moving carefully beneath thick vegetation. Yet hidden within those seemingly ordinary animals was extraordinary potential. Over immense spans of time, their descendants would become elephants wandering across African savannas, bats navigating the night sky with remarkable precision, dolphins swimming through coastal waters, and primates climbing the branches of tropical forests. Those futures were impossible to see at the time, but evolution has often begun with creatures that seemed completely unremarkable. These plates float upon softer layers of rock deep below the surface, gradually shifting only a few centimeters each year. Although that movement appears insignificant, it has shaped the planet over hundreds of millions of years. Rivers respond by carving new valleys, coastlines shift with changing sea levels, and climates evolve alongside these geological transformations. The world is never truly motionless. It simply changes at a pace that is almost impossible for us to perceive. Some mammals remained within the shelter of the forests, while others slowly ventured into wetlands, open woodlands, river valleys, and coastal environments. No creature living at the time could have realized that these quiet changes would eventually lead to giant ground sloths, saber-toothed cats, mammoths, whales, elephants, horses, and even ourselves. Yet the conditions that made all of those remarkable animals possible were already developing, one generation at a time, across a recovering planet that had entered the long and fascinating age of mammals. Tropical and subtropical forests extended across regions that are cool or even frozen in the present day. Palm trees grew in places where winter snow would eventually become common, and broad leaf forests stretched across vast areas of the northern hemisphere. There were no permanent ice sheets covering Antarctica or Greenland. Instead, much of the world enjoyed mild conditions that allowed plants and animals to flourish over enormous distances. One of the most remarkable discoveries made by paleontologists is just how far north some warmth-loving animals once lived. Fossils of crocodile relatives have been uncovered in regions that today experience long, freezing winters. Oceans, volcanoes, mountain building, changing atmospheric gases, and the movement of continents all played their part in shaping these long cycles. They were not uniform woodlands, but incredibly diverse ecosystems filled with towering trees, flowering plants, ferns, mosses, fungi, and countless forms of animal life. Streams wound quietly beneath the trees, carrying fresh water through landscapes alive with bird song and the distant sounds of insects. Fallen logs slowly decayed beneath blankets of moss, providing homes for small animals and nourishing the next generation of plants. Every part of the forest was connected, each living thing depending in some way upon another. For the mammals living there, these forests offered both opportunity and challenge. Dense vegetation provided excellent shelter from predators, while branches, hollow trunks, and tangled undergrowth created countless places to hide or raise young. Food could often be found throughout the year in the form of fruit, seeds, leaves, insects, and small animals. At the same time, moving through such crowded environments required agility and awareness. Animals that climbed well could reach food unavailable to those on the ground. Those with sharp hearing or keen senses of smell gained valuable information about approaching danger. Others developed powerful limbs for digging burrows where they could rest safely during the day. Each species slowly adapted to its surroundings, not through sudden changes, but through countless generations of small improvements that increased the chances of survival. When scientists study fossils from this period, they often find animals that seem to combine familiar and unfamiliar features. Some possess teeth that resemble those of modern mammals, yet their bodies belong to groups that no longer exist. Others look surprisingly ordinary, despite representing the earliest members of lineages that would later spread across the globe. Evolution rarely produces entirely new designs all at once. Instead, it gently reshapes existing forms, preserving what works while gradually modifying other features. Over enough time, those gradual adjustments can produce creatures so different from their distant ancestors that the relationship is almost impossible to recognize without the evidence preserved in stone. The fossil record is remarkable because it allows scientists to observe these slow transformations across immense stretches of time. Individual fossils provide only brief glimpses into ancient lives, yet when thousands of discoveries are compared, clear patterns begin to emerge. Skeletons reveal changing proportions, teeth record shifts in diet, and even tiny bones inside the ear can reveal how an animal experienced the world around it. Every carefully excavated fossil adds another piece to an enormous puzzle that has been assembled by generations of researchers working across deserts, cliffs, river valleys, and windswept plains. There was no guarantee that any particular group would succeed. Many lineages flourished for a time before disappearing completely, leaving no descendants alive today. Others survived through changing climates, shifting continents, and fierce competition, eventually giving rise to animals that remain familiar to us. Extinction and survival have always existed side by side throughout the history of life. While one branch of the evolutionary tree quietly ended, another continued growing, producing new forms adapted to changing environments. The diversity of mammals that surrounds us today represents only a small fraction of the countless evolutionary paths that were explored during the Cenozoic. As the warm forests continued spreading across much of the planet, another quiet transformation was beginning beneath their leafy canopies. Among the many small mammals moving through the undergrowth were species whose descendants would eventually leave the forests behind altogether. Others would become larger as new sources of food became available. As millions of years passed, mammals became increasingly diverse, exploring ways of life that had scarcely been possible while giant dinosaurs dominated the land. Some remained small enough to disappear beneath fallen leaves, while others slowly grew larger as they adapted to new environments. Every available habitat offered its own challenges and rewards. Dense forests favored animals that could climb with confidence or move silently through tangled vegetation. Riverbanks rewarded those able to swim or search for food in shallow water. Open woodland encouraged longer legs and sharper eyesight, while underground burrows protected creatures that preferred a life hidden from the world above. Evolution was not working towards a final goal. It simply favored whatever traits allowed each generation to survive a little more successfully than the one before. Many of these early mammals would appear rather unusual to modern eyes. They belong to families that have no living representatives, making them difficult to compare with today's animals. Some possessed heavy bodies balanced upon surprisingly short legs, while others carried long tails that helped them maintain balance among branches. Teeth varied enormously from one species to another, reflecting the wide range of foods available within these recovering ecosystems. Some specialized in crushing tough seeds, while others fed upon insects hidden beneath bark or among leaf litter. Although few reached impressive sizes during these earlier stages, they demonstrated that mammals were capable of adapting to almost every opportunity nature presented. One characteristic helped mammals succeed in ways that often go unnoticed. Unlike reptiles, which generally rely upon external temperatures to regulate their bodies, mammals produce their own body heat through an active metabolism. Thick fur provided insulation, protecting them from changing temperatures, while also helping young animals survive during their vulnerable early weeks. Mothers produced milk, nourishing their offspring with a dependable source of food until they were strong enough to feed themselves. As forests matured, they became extraordinarily complex places where every layer supported different forms of life. High above the ground, birds moved through the canopy, searching for fruit, insects, and nesting places among the branches. Sunlight filtering through the leaves created shifting patterns across the forest floor, where countless insects, fungi, and small animals carried out their quiet daily routines. Fallen trees slowly decayed, returning nutrients to the soil, while creating shelter for creatures that preferred cool, damp hiding places. Streams meandered beneath overhanging branches, carrying fresh water through the landscape and supporting fish, amphibians, and aquatic plants. Even the smallest patch of woodland contained an astonishing number of interconnected relationships, each depending upon the health of the wider ecosystem. The warm climate of the early Cenozoic also encouraged an incredible variety of flowering plants. Millions of years earlier, these plants had first appeared during the age of the dinosaurs, but they now expanded into countless new habitats. Their colorful flowers attracted insects that carried pollen from one plant to another, allowing reproduction to occur with remarkable efficiency. Fruits developed to encourage animals to eat them, with seeds passing safely through digestive systems before being deposited elsewhere. This partnership benefited both sides. Plants spread into new areas, while mammals and birds gained reliable sources of nutrition. Relationships like these demonstrate that evolution is often built upon cooperation as much as competition. Entire ecosystems became more diverse because different species gradually found ways to benefit from one another. While life flourished on land, the oceans were also recovering from the extinction event. Marine ecosystems had suffered enormous losses alongside those on land, yet they too slowly regained their richness. Coral reefs began expanding once again, fish diversified into newly available habitats, and marine reptiles that had dominated the seas during the age of the dinosaurs were gone. Their disappearance created opportunities for other groups to occupy the oceans. At this stage, however, whales did not yet exist. The largest mammals remained entirely land-dwelling, while the seas were inhabited primarily by fish, sharks, turtles, and countless smaller organisms. Few could have imagined that some ordinary-looking mammals walking along riverbanks would eventually produce creatures larger than any animal the Earth had ever known. As scientists continue uncovering fossils from rocks formed during these early millions of years, they are often reminded that nature rarely moves in straight lines. Evolution produces many experiments. Some become tremendously successful and persist for millions of years. Others disappear almost as quietly as they appeared. Looking back across the Cenozoic, it becomes clear that survival has never depended upon being the strongest or the largest. Instead, the most successful animals were often those capable of adapting when circumstances changed. Flexibility, patience, and the ability to take advantage of new opportunities repeatedly shaped the course of life's history, allowing certain groups to endure while others gradually vanished. By now, the Earth had recovered far beyond what anyone might have imagined in the dark years immediately following the asteroid impact. Yet this was still only the beginning of a much longer transformation. Hidden among these thriving forests were animals whose descendants would eventually leave the trees behind, grow to astonishing sizes, reshape entire ecosystems, and even return to the sea. One group of mammals in particular was beginning a journey unlike any other. Although they still spent their lives entirely on land, some species gradually developed features that would eventually allow their distant descendants to thrive in places far removed from the forests where their ancestors once lived. Evolution did not suddenly create entirely new animals. Instead, it gently modified existing ones, with each generation differing only slightly from the last. Over millions of years, those almost invisible differences accumulated until familiar creatures emerged from ancestors that would scarcely be recognized today. Water offered reliable food, especially for animals willing to search along muddy banks for fish, shellfish, insects, or other small creatures. The margins between land and water became places of opportunity where mammals encountered environments unlike anything deeper within the forests. Soft ground preserved footprints, reeds sheltered nesting birds, and slow-moving streams reflected the warm skies above. Animals that spent increasing amounts of time near these waterways gradually developed traits that made them more comfortable in shallow water. The ancestors of whales did not resemble the graceful giants we know today. They looked far more like ordinary four-legged mammals, walking confidently across the land while occasionally entering rivers or coastal waters in search of food. If you had observed them without knowing what lay millions of years ahead, you would never have guessed that their descendants would one day cross entire oceans, communicate across astonishing distances, and grow larger than any dinosaur that had ever lived. Their future remained hidden within gradual evolutionary changes that no individual animal could possibly notice during its lifetime. The idea that whales descended from land mammals once seemed almost impossible to believe. Early naturalists struggled to understand how such enormous marine animals could share common ancestry with creatures that walked upon four legs. It was only through decades of fossil discoveries that scientists slowly assembled the evidence. Each newly discovered skeleton revealed another stage in the transition, showing animals that possessed a fascinating mixture of characteristics. Some retained sturdy legs capable of supporting their weight on land, while also displaying adaptations for swimming. Others spent more of their lives in the water, with limbs gradually becoming better suited for paddling than walking. None of these changes happened quickly. Together, they formed one of the clearest examples of evolution unfolding through deep time. While some mammals explored life near the water, others remained firmly rooted on land and continued expanding into new habitats. The forests were no longer the only environments available. In some regions, the trees became more widely spaced, creating open woodlands where sunlight reached the ground more easily. These landscapes supported different plants, attracting herbivores that grazed among shrubs and young trees. Predators followed their prey, while smaller mammals searched for seeds, insects, and fallen fruit scattered across the woodland floor. The Cenozoic was becoming a time of constant experimentation, with evolution quietly testing countless possibilities across the continents. Among the most important forces shaping this changing world was the movement of the continents themselves. Although impossible to notice during a human lifetime, the Earth's tectonic plates continued drifting at roughly the same speed that fingernails grow. As continents shifted into new positions, ocean currents also changed. Warm water flowing around the globe carried heat from one region to another, influencing rainfall, temperatures, and seasonal weather patterns. When mountain ranges slowly rose, they redirected winds and forced moist air upwards, creating rain on one side while leaving the opposite slopes much drier. Animals were constantly adapting to a planet that never truly stood still. One of the most dramatic examples of this slow geological activity involved the continent of India. For millions of years it traveled steadily northward across the ancient ocean that once separated it from Asia. Eventually, the two enormous landmasses collided with tremendous force. Because both continents were composed of relatively light continental crust, neither easily sank beneath the other. Instead, the land crumpled and folded upwards, creating the beginnings of the Himalayan mountains. Although this collision unfolded over tens of millions of years, it continues even today. The Himalayas still rise by a tiny amount each year, reminding us that the Earth remains an active planet, despite appearing solid and unchanging beneath our feet. As mountain ranges slowly climbed higher, they influenced far more than the surrounding scenery. They altered rainfall patterns, changed the courses of rivers, and created new habitats at different elevations. Animals living near the growing mountains gradually adapted to cooler temperatures, steeper terrain, and changing vegetation. Plants colonized newly formed valleys, while streams carried minerals from the mountains towards distant plains. Every geological event, no matter how slow, created fresh opportunities for life to diversify. The evolution of mammals cannot be understood without recognizing that the land beneath them was evolving as well. The history of life and the history of the Earth have always been closely connected, each shaping the other across the vast expanse of geological time. As these gradual transformations continued, the warm forests of the early Cenozoic still covered much of the planet, but subtle signs of future change were beginning to appear. Temperatures would not remain so consistently warm forever. Over the millions of years ahead, climates would slowly cool, forests would retreat from some regions, and entirely new ecosystems would emerge in their place. Instead of moving beneath a continuous canopy of trees, they crossed patches of woodland separated by sunlit clearings. These open spaces exposed animals to new challenges. There was less cover from predators, longer distances between sources of food, and a greater need to travel efficiently across the landscape. Even small changes in the environment could influence which individuals survived long enough to produce offspring. Those that could move a little faster, see a little farther, or cover greater distances with less effort often gained a valuable advantage. Over immense spans of time, natural selection slowly favored traits that were better suited to these changing conditions. Among the mammals responding to these new environments were the distant ancestors of modern horses. The earliest members of this remarkable lineage bore little resemblance to the powerful animals that gallop across fields today. They were small creatures, standing only about the height of a medium-sized dog. Their backs were gently curved, their necks were relatively short, and instead of ending in a single hoof, each foot possessed several toes. These toes spread their weight across the soft forest floor, making it easier to walk over damp soil covered with fallen leaves and decaying branches. They browsed quietly among low shrubs and young plants, living in habitats where speed was less important than agility and careful movement through dense vegetation. One of the earliest known members of this family is an animal called Eohippus, a name that means dawn horse. It lived during the early part of the Cenozoic and measured little more than 60 centimeters at the shoulder. Although it is often described as the first horse, scientists now understand that horse evolution was more complex than once believed, with several closely related early species contributing to the lineage. The teeth of these early horses also reveal much about the world in which they lived. They possessed relatively low crowned teeth that were well suited for eating soft leaves, tender shoots, and other vegetation found within forests. Their food required little grinding, because the plants had not yet evolved the tough, silica-rich tissues that would later become common in many grasses. Every bite reflected the environment around them. Scientists often study fossil teeth because they preserve exceptionally well, and they provide valuable clues about ancient diets, climates, and ecosystems. The gradual transformation of horses demonstrates one of the most fascinating principles in evolution. Animals do not change because they decide to adapt or because they somehow anticipate future environments. Instead, natural variation already exists within every population. Some individuals are born slightly larger, others slightly faster, while some possess stronger teeth or longer legs. When the environment changes, those natural differences may become more or less useful. Individuals with favorable characteristics are often more likely to survive and produce offspring, passing those traits to the next generation. This change did not happen everywhere at the same time. Some areas remained heavily forested, while others became increasingly dry, allowing grasses to spread across the landscape. Grass may seem ordinary today, yet its expansion was one of the most significant ecological developments in the history of the Cenozoic. It transformed entire continents, altered the diets of countless animals, and created opportunities for new forms of life to flourish. What appears to us as a simple green field is actually the result of millions of years of evolutionary innovation by plants remarkably well adapted to survive grazing, drought, and even fire. Unlike many forest plants, grasses grow from the base rather than from the tip of each leaf. This unusual arrangement allows them to continue growing even after being eaten by grazing animals. Their leaves also contain tiny particles of silica, a mineral that makes them more resistant to damage, but also creates an unexpected challenge for herbivores. As animals repeatedly fed upon these grasses, the silica gradually wore down their teeth, like very fine sandpaper. Mammals that possess stronger, higher crowned teeth were better able to cope with this abrasive diet, and therefore enjoyed an advantage as grasslands expanded. Over millions of years, the spread of grasses influenced the evolution of countless grazing mammals, including the ancestors of horses. The ancestors of horses responded in several ways to these changing landscapes. Their legs gradually became longer, allowing them to travel greater distances while using less energy. The middle toe on each foot became stronger and larger, while the outer toes slowly diminished in importance. Eventually, most of the animal's weight came to rest upon a single enlarged toe, protected by a hard hoof. This design proved remarkably effective for running across firm ground at high speeds. The spine, muscles, and tendons also changed, creating an efficient body capable of sustained movement over open country. Had the forests remained unchanged forever, horses might never have developed the long legs and powerful hooves that make them so recognizable today. Instead, shifting climates, expanding grasslands, and changing ecosystems created new opportunities that rewarded different characteristics. The landscape shaped the animals, while the animals gradually became part of the landscape itself. It transformed entire ecosystems, creating one of the greatest evolutionary opportunities in the history of mammals. Open plains stretched for hundreds of kilometers in some regions, covered with grasses that swayed gently beneath the wind. Unlike forests, where trees blocked the view after only a short distance, these broad landscapes offered clear sightlines across the horizon. Animals could often see one another from far away, making speed, endurance, and awareness more important than ever before. The world had become a place where survival often depended upon reaching the safety of the herd before a predator could close the distance. As grazing mammals became more numerous, predators also began changing in response. On open grasslands, however, the challenge was very different. There were fewer places to hide, and prey animals could detect danger from much greater distances. Predators that possessed longer legs, greater stamina, and sharper senses often enjoyed an advantage. Some relied upon bursts of speed, while others depended upon persistence, gradually exhausting their prey over long pursuits. Every improvement in a predator's hunting ability encouraged prey animals to become slightly faster, more alert, or better able to escape. This continuous relationship between hunter and hunted shaped both groups over countless generations. The spread of grasslands also encouraged the formation of large herds. Living in groups offered important advantages in open country. Many pairs of eyes were better than one at spotting danger approaching across the plains. Young animals gained protection by remaining close to experienced adults, while predators often found it more difficult to isolate a single individual from a tightly packed herd. Moving together also allowed grazing mammals to travel efficiently between feeding areas as the seasons changed. Even today, the great migrations of wildebeest, zebras, and antelope across the African savanna provide a glimpse into a way of life that has deep roots within the Cenozoic. Although we often imagine ancient grasslands as empty stretches of waving vegetation, they were remarkably diverse environments. Wildflowers bloomed among the grasses during favorable seasons, attracting insects that pollinated countless plant species. Small mammals dug extensive tunnel systems beneath the soil, creating homes that also provided shelter for reptiles, insects, and other animals. Birds nested on the ground or hunted from the air, while larger herbivores grazed peacefully across the open landscape. Beneath the surface, earthworms, fungi, and microscopic organisms continually recycled nutrients, helping grasses recover after being eaten or trampled. Every level of the ecosystem depended upon another, creating a living network that stretched from the smallest soil bacteria to the largest mammals. Grasses themselves became extraordinary survivors. Many species could withstand repeated grazing because their growing tissues remained close to the ground, safely below the reach of browsing animals. Even after being eaten, they quickly produced new leaves. Their extensive root systems reached deep into the soil, allowing them to survive dry periods that would challenge many other plants. Some grasses even benefited from occasional fires, rapidly returning after flames had cleared away competing vegetation. As the landscapes changed, mammals continued adapting alongside them, producing an astonishing variety of grazing species. The fossil record reveals that this transition unfolded over millions of years, rather than happening all at once. Layers of ancient sediments preserve pollen grains, leaves, seeds, and fossil soils that allow scientists to reconstruct long-vanished environments. Fossilized teeth provide additional evidence because animals feeding primarily on grasses develop different patterns of wear than those browsing on leaves. Every discovery adds another piece to our understanding of how changing climates reshaped ecosystems across the Cenozoic. The evidence comes from many different sources, yet together they tell a remarkably consistent account of a planet slowly transforming before our eyes. As grazing mammals became increasingly successful, some lineages grew to impressive sizes. Larger bodies allowed herbivores to travel longer distances, store more energy, and better defend themselves against predators. Great herds wandered across ancient plains, shaping the vegetation through constant grazing. Their hooves disturbed the soil, creating opportunities for fresh plants to grow, while their waste returned valuable nutrients to the ground. In this way, the animals were not simply living within the grasslands, they were actively helping maintain the ecosystems upon which they depended. Similar relationships can still be observed today, where large grazing mammals influence everything from plant diversity to the movements of smaller animals sharing the same habitat. The changing landscapes also encourage mammals to become increasingly specialized. Some evolved digestive systems capable of extracting nutrients from tough grasses that few other animals could digest efficiently. Others developed powerful jaws and large grinding teeth designed for processing enormous quantities of vegetation every day. Certain species remained selective feeders, choosing only particular plants, while others became generalists, able to survive on a wide variety of foods, depending upon seasonal conditions. This diversity reduced competition, allowing many different herbivores to share the same landscape while relying upon slightly different resources. Evolution often succeeds not by producing identical animals, but by encouraging countless variations that each occupy a unique place within the ecosystem. By this stage of the Cenozoic, the age of mammals had become unmistakable. Forests still covered many parts of the world, but vast grasslands now stretched across other continents, supporting an ever-increasing variety of grazing animals and the predators that followed them. Among the many remarkable mammals living during this time were species unlike anything alive today, creatures with enormous bodies, unusual skulls, and surprising adaptations that remind us evolution has often explored paths far stranger than our imaginations might invent. Some of the most fascinating mammals of the early Cenozoic belong to groups that have no close living relatives. Their extinction does not mean they were poorly adapted. Quite the opposite is often true. Many flourished across vast regions and occupied important ecological roles for extraordinarily long periods. Even highly successful animals can fade away when the environments around them continue changing over immense spans of time. Among these remarkable creatures were the Euanthatheres, large herbivorous mammals that first appeared during the Eocene epoch. At first glance, they looked rather like a mixture of several modern animals without closely resembling any one of them. Their bodies were broad and heavy, supported by sturdy legs that carried them steadily through ancient forests and open woodlands. Their most striking feature was the unusual shape of their skulls. Several pairs of rounded bony projections rose from the top of the head, giving them an appearance unlike any mammal alive today. These were not true horns like those of cattle or antelope. Instead, they were solid bony structures covered by skin during life. Scientists are still uncertain exactly how they were used, although they may have played a role in displays between rivals or in establishing dominance during the breeding season. Despite their unusual appearance, Uintathers were peaceful plant eaters. Their teeth suggest they fed upon soft leaves, shoots, and other vegetation rather than tough grasses. Their enormous size offered protection from many predators, reducing the need for speed. Instead of relying upon quick escapes, they depended upon their powerful build and the simple fact that few hunters would willingly challenge such a formidable animal. They remind us that evolution often favors many different solutions to the same problem. While some mammals survived through speed and agility, others succeeded by becoming impressively large. Their name means thunder beasts, although there is no evidence that they made particularly thunderous sounds. They were distant relatives of modern horses, tapirs, and rhinoceroses, yet they followed a very different evolutionary path. Some species grew to the size of modern rhinoceroses, with long legs supporting heavy bodies and massive skulls. Near the ends of their snouts, they developed distinctive paired bony structures that formed a broad fork-shaped projection. Like the skull ornaments of the Uintatheres, these were made of bone rather than true horn. They may have been used in contests between males, where rivals pushed against one another to establish dominance without causing serious injury. The world inhabited by the Brontotheres was one of remarkable abundance. Browsing mammals could find food throughout much of the year, allowing several large herbivorous species to live side by side while feeding upon slightly different vegetation. Some preferred leaves from taller shrubs, while others specialized in softer plants growing closer to the ground. These subtle differences reduced competition and allowed many species to share the same habitats. Modern ecosystems work in much the same way. Even animals that appear similar often depend upon different food sources, feeding at different heights or during different times of the day. When paleontologists compare the skeletons of these extinct mammals with those of living species, they often discover surprising relationships. Animals that look very different on the outside may share common ancestors, while creatures that appear almost identical can belong to entirely separate branches of the evolutionary tree. This is because evolution sometimes produces similar solutions when unrelated animals face similar environmental challenges. A large browsing mammal may develop a heavy body, sturdy limbs, and broad grinding teeth, regardless of whether its closest relatives are horses, elephants, or another group altogether. This process, known as convergent evolution, demonstrates that nature often arrives at comparable designs through completely different evolutionary histories. If we could travel back to the middle of the Cenozoic, many of the largest mammals we encountered would be unfamiliar, despite belonging to groups that once flourished across entire continents. The elephants, giraffes, deer, cattle, and horses we recognize today were still evolving, while many dominant herbivores belong to families that have since vanished. Every age has its characteristic animals. The creatures we think of as ordinary today might seem just as unusual to someone living tens of millions of years in the future, assuming our own species has become part of the fossil record by then. Studying these extinct mammals also reveals how incomplete our knowledge can sometimes be. Fossils preserve bones far more readily than soft tissues, so scientists must often reconstruct muscles, skin, fur, and color using indirect evidence. A beautifully preserved skeleton may reveal the size and proportions of an animal with remarkable accuracy, while leaving its appearance in life open to careful interpretation. Did the skin carry bold patterns or gentle shades of brown and gray? Was the fur thick or sparse? Were the bony projections brightly colored during the breeding season? These questions are difficult to answer with certainty, yet every new discovery helps refine our understanding of animals that disappeared millions of years before humans ever existed. Although many of these strange mammals eventually became extinct, they played an important role in the continuing evolution of life on Earth. They browsed forests, dispersed seeds, shaped vegetation, and influenced the predators that hunted alongside them. Their lives formed part of an enormous ecological network that continued changing from one age to the next. The age of mammals was never a single unchanging period. It was a time of continual renewal, with each generation quietly preparing the way for those that followed. As remarkable as the Uintatheres and Brontotheres were, they represented only a few of the many evolutionary experiments taking place during the Cenozoic. The fossil record is filled with mammals that followed unusual paths before eventually disappearing, each adapted to the particular world in which it lived. Some developed powerful digging limbs that allowed them to spend much of their lives underground. Others became expert climbers, moving confidently through the forest canopy in search of fruit, leaves, and insects. There were animals with elongated snouts for feeding among soft vegetation, compact bodies built for pushing through dense undergrowth, and specialized teeth capable of processing foods that few other mammals could digest. Looking across the millions of years of the Cenozoic, it becomes clear that evolution was constantly exploring new possibilities, producing forms of life that often seem far stranger than fiction. Many of these extinct mammals shared one important characteristic. They were perfectly adapted to the environments in which they lived. A species may thrive for 10 or even 20 million years before changing climates, shifting landscapes, or increased competition gradually reduce its numbers. By comparison, modern humans have existed for only a small fraction of that time. Some extinct mammals endured for periods so long that their entire history would seem almost unimaginable from a human perspective. One lesson repeated throughout the fossil record is that nature rewards flexibility. Environments rarely remain the same forever. Animals able to adjust to these changes often survive, while those with very specialized lifestyles sometimes struggle when their preferred habitats begin to disappear. This pattern has occurred repeatedly throughout Earth's history. Every generation inherited a world that differed, however slightly, from the one experienced by its parents. Scientists have learned an extraordinary amount about these ancient mammals by studying more than just their bones. Tiny chemical signatures preserved within fossil teeth can reveal the kinds of plants an animal consumed during its lifetime. The microscopic patterns of wear across the surface of those teeth provide additional clues about whether it browsed on leaves, grazed on grasses, or fed upon tougher vegetation. Even the surrounding rocks offer valuable information. Layers of ancient river sediments suggest flowing water once crossed the landscape, while fossil pollen reveals which plants grew nearby. Every discovery adds another small piece to an enormous picture that continues becoming clearer with each passing decade. Two mammals may look quite similar because they evolved to solve the same problems, even though they are only distantly related. At the same time, close relatives can eventually become so different that their shared ancestry is difficult to recognize without careful scientific study. Modern whales and hippopotamuses provide a fascinating example. At first glance, they seem to have very little in common. One spends its entire life in the ocean, while the other grazes along African rivers and lakes. Yet genetic studies and fossil discoveries have shown that whales are more closely related to hippopotamuses than to any other living mammals. Their common ancestor lived tens of millions of years ago, long before either modern group had taken on its familiar appearance. This surprising relationship demonstrates that evolution often follows paths we would never guess simply by looking at living animals. No ecosystem remained exactly the same forever. Forests expanded during warmer periods before retreating as climates cooled. Lakes formed and eventually dried away. Rivers shifted their channels across broad floodplains, leaving behind layers of sediment that would one day preserve the fossils of animals drinking from their banks. Volcanic eruptions created new landscapes, while erosion slowly wore older mountains into gentler hills. Every process unfolded at its own pace, some taking only a few years, others requiring millions of years before their full effects became visible. Together they created an ever-changing world that continually presented new challenges and opportunities for life. The warm greenhouse conditions that had dominated much of the early Cenozoic would not last indefinitely. Tiny changes in atmospheric composition, the continued movement of the continents, and the steady uplift of great mountain ranges slowly influenced global temperatures. These changes happened so gradually that no individual animal could ever perceive them, yet generation after generation experienced environments that became subtly different from those known by their ancestors. Great grazing animals became increasingly common, while predators evolved alongside them, each influencing the other's development through millions of years of natural selection. The Earth was entering another important stage of the age of mammals, one that would eventually produce some of the most recognizable animals in prehistoric history. Among them were creatures of immense size, powerful strength, and extraordinary endurance, including the distant relatives of the elephants that still walk the earth today. Among the most successful mammals to emerge during the Cenozoic were the proboscideans, the remarkable group that includes today's elephants, along with dozens of extinct relatives. Modern elephants represent only a small surviving branch of an evolutionary family tree that was once astonishingly diverse. Over the course of millions of years, proboscideans spread across Africa, Europe, Asia, and eventually North and South America, adapting to forests, grasslands, wetlands, and even the cold environments of the ice ages. Their story is not simply one of growing larger. The earliest known proboscideans were surprisingly modest animals. One of the oldest was Moeritherium, which lived about 37 million years ago in what is now northern Africa. Standing only around the height of a large pig, it looked nothing like the towering elephants familiar to us today. Its body was long and low, supported by relatively short legs, and it probably spent much of its time near rivers, lakes, and marshes. Scientists believe it fed upon soft aquatic plants and vegetation growing along the water's edge. Although it may have possessed a slightly enlarged upper lip or a very short trunk, it certainly lacked the long, muscular trunk that would later become one of the defining features of elephants. Looking at Moeritherium, few people would immediately recognize it as one of the earliest members of the elephant family. As millions of years passed, later proboscideans gradually became larger and more specialized. This remarkable structure contains tens of thousands of individual muscles and serves many purposes throughout an elephant's daily life. It functions as a hand for gathering food, a hose for drawing water, a tool for lifting branches, and even a sensitive organ capable of detecting subtle scents carried upon the breeze. The evolution of the trunk allowed elephants and their ancestors to reach food without lowering their heads, making it easier to browse from trees, gather grasses, or drink from rivers while remaining aware of their surroundings. Tusks also underwent an extraordinary transformation during the Cenozoic. They are actually greatly enlarged incisor teeth that continue growing throughout much of an elephant's life. In some extinct relatives, they remained relatively straight, while in others, they curved dramatically. A few species developed long downward-pointing tusks that projected beneath the lower jaw, giving them an appearance unlike any living mammal. One particularly unusual genus, called Platybelodon, possessed a broad, flattened lower jaw that resembled a large shovel. Scientists believe it may have used this specialized jaw and its lower tusks to strip soft vegetation from marshes or scrape aquatic plants from muddy ground. Although this adaptation eventually disappeared, it demonstrates how creatively evolution explored different ways of solving similar challenges. The increasing size of many proboscideans brought important advantages. A larger body allowed these mammals to travel great distances in search of food and water, while storing more energy than smaller animals. Their height enabled them to browse leaves beyond the reach of many other herbivores, reducing competition for food. Thick skin provided protection from branches, insects, and changing weather, while their impressive size discouraged many predators from attempting an attack. Even so, young calves remained vulnerable during their earliest years, making family groups an important part of survival. Evidence from living elephants suggests that strong social bonds have deep evolutionary roots, and many extinct proboscideans may also have lived in herds where adults worked together to protect younger members. The environments occupied by these animals varied enormously throughout the Cenozoic. Some species preferred warm forests, where abundant vegetation grew throughout the year. Others became perfectly suited to open grasslands, feeding across broad plains beneath wide skies. As climates gradually cooled during later parts of the era, several proboscideans adapted to much colder conditions than their earliest ancestors had ever experienced. Thick coats of hair, layers of insulating fat, and changes in body proportions eventually allowed certain species to thrive in landscapes that would have seemed impossible during the warm forests of the early Cenozoic. Their influence upon the landscape was considerable. Large herbivores do far more than simply consume vegetation. As they travel, they create paths through dense woodland, open clearings where sunlight reaches the ground, and disperse seeds over great distances through their droppings. Trees damaged by browsing often produce fresh growth, while disturbed soil creates opportunities for new plants to establish themselves. Modern elephants are sometimes called ecosystem engineers because their daily activities reshape the habitats around them. Countless smaller animals benefited from these changes without any awareness of the giant mammals responsible for them. The fossil record preserves many remarkable examples of these ancient giants. Entire skeletons have been uncovered from river deposits, ancient lake beds, and sediments that were once broad floodplains. Occasionally, scientists discover groups of individuals preserved together, suggesting that they may have traveled as herds, much like living elephants. Their footprints have also survived in some places, frozen into layers of soft mud that later hardened into stone. These fossil trackways reveal not only the size of the animals, but sometimes the way they move together across the landscape. Young individuals often appear walking safely between larger adults, providing a quiet glimpse into family life that has remained untouched for millions of years. As the Cenozoic continued unfolding, the elephant family kept diversifying into an extraordinary variety of forms. Some lineages disappeared, while others flourished, each responding to the changing climates and landscapes of their time. Among those later descendants would be one of the most iconic mammals of prehistory, an animal perfectly adapted to the cold grasslands that spread across much of the northern hemisphere during the Great Ice Ages. As the climates of the Cenozoic continued their slow transformation, the planet began moving away from the prolonged warmth that had characterized much of its earlier history. The change was almost unimaginably gradual. No single generation of animals experienced a dramatic shift, and no forest disappeared within the lifetime of a single tree. The Earth was entering a new phase, one that would eventually prepare the planet for the great ice ages that still lay far in the future. One of the most important events during this long cooling trend took place far to the south. Antarctica, which had once supported forests filled with a surprising variety of plants and animals, slowly became more isolated as the surrounding continents drifted into new positions. Eventually, a powerful ocean current began flowing completely around the continent. This current acted like a natural barrier, reducing the amount of warm tropical water that could reach Antarctica. As the continent became increasingly isolated from warmer oceans, temperatures gradually fell, and permanent ice sheets began forming across its surface. Although Antarctica was becoming colder, many parts of the world remained rich with life. Some species thrived in humid woodlands, while others became specialists of dry, open country. Rivers carried fresh water from rising mountain ranges towards fertile plains, supporting ecosystems that changed subtly from one region to another. The Cenozoic was never a single uniform world. It was a collection of countless environments, each influencing the animals that lived there in slightly different ways. Together, these habitats encouraged an extraordinary level of biodiversity across the planet. The cooling climate also encouraged plants to evolve alongside the changing conditions. Some trees became better suited to surviving cooler winters, while others gradually disappeared from regions that no longer provided the warmth they required. Deciduous forests, where trees shed their leaves during colder seasons, became increasingly widespread in many parts of the northern hemisphere. This adaptation allowed trees to conserve water and energy during times when growing conditions were less favorable. As habitats diversified, so too did the mammals that depended upon them. Some evolved thicker coats of fur to cope with cooler temperatures, while others developed broader diets that allowed them to survive seasonal changes in food availability. Animals capable of storing fat gained an advantage during periods when vegetation became less abundant, and many species adjusted their breeding seasons so that their young would be born when food was most plentiful. These were not sudden innovations, but gradual responses shaped over countless generations. The fossil record preserves many examples of changing body proportions, tooth structures, and limb designs that reflect the slow adaptation of mammals to an increasingly varied climate. The continued uplift of major mountain ranges also influenced this changing world. As the Himalayas grew higher through the ongoing collision between India and Asia, they altered atmospheric circulation across much of the surrounding region. Moist air rising over the mountains released rain on one side, while creating much drier conditions beyond them. Valleys sheltered forests, high elevations supported cooler ecosystems, and broad plains beyond the mountains often became increasingly dry. Mammals responded by adapting to these regional differences, producing new species that were finely suited to the environments in which they lived. The movement of continents, the growth of mountain ranges, the circulation of ocean currents, and the composition of the atmosphere all influence one another over geological time. Even small adjustments can produce significant effects when they continue for millions of years. The relationship between geology and biology became increasingly apparent as every environmental change encouraged new evolutionary possibilities. By the later part of the Cenozoic, the world contained ecosystems that would begin to look more familiar to modern eyes. Yet one important difference still remained. The repeated advances and retreats of enormous continental ice sheets had not yet reached their greatest extent. Those dramatic cycles of freezing and warming were still developing, and when they eventually arrived, they would transform the appearance of much of the northern hemisphere. Entire landscapes would be sculpted by moving ice, sea levels would rise and fall, and some of the most iconic mammals in Earth's history would spread across the cold grasslands that stretched from Western Europe to North America. Among those future inhabitants would be woolly mammoths, shaggy rhinoceroses, giant deer with antlers spanning several meters, powerful bison, and many other remarkable animals perfectly adapted to life in cold environments. Their arrival, however, was only possible because of the millions of years of gradual environmental change that had already taken place. The age of mammals continued moving steadily forward, and with each passing million years, the planet drew closer to one of the most distinctive periods in its long and fascinating history. The repeated advance and retreat of great ice sheets transformed far more than the appearance of the landscape. Each colder period locked enormous quantities of water within glaciers that spread across large portions of the northern hemisphere. As water became trapped in ice, sea levels gradually fell, exposing land that today lies beneath the oceans. During warmer intervals, the glaciers slowly melted, rivers swelled with fresh water, and the seas once again rose to cover the coastlines. This natural cycle repeated many times throughout the later Cenozoic. Every advance of the ice reshaped valleys, carved new lakes, redirected rivers, and scattered immense boulders across the countryside. Many of the hills, lakes, and broad valleys visible in northern Europe, Canada, and parts of the United States still bear the unmistakable marks left behind by these ancient glaciers. Although we often picture the Ice Age as a frozen world buried beneath endless snow, the reality was far more varied. The largest glaciers occupied only certain regions, while vast stretches of land beyond their edges remained open and surprisingly dry. Much of northern Eurasia and North America was covered not by forests, but by a unique ecosystem known as the mammoth steppe. During the short summers, hardy grasses, flowering plants, and low shrubs flourished beneath almost continuous daylight in the far north. The winters were long and bitterly cold, yet the dry climate prevented the heavy snowfall that many people associate with polar regions today. Instead of deep snowdrifts, much of the ground remained exposed, allowing large herbivores to continue grazing throughout much of the year. The mammoth steppe stretched across thousands of kilometers, forming an almost continuous belt from Western Europe through Siberia and across the land bridge that once connected Asia and North America. Today, the Bering Strait separates those continents, but during colder periods, sea levels fell low enough to expose a broad plain known as Beringia. Rather than serving merely as a narrow crossing point, Beringia was itself a thriving ecosystem filled with grasses, shrubs, rivers, and wildlife. For thousands of years, animals moved freely between the continents, gradually expanding their ranges without any awareness that future oceans would eventually separate these lands once again. Many of the great mammals of the Ice Age spread across this route, while much later, it also provided a pathway for some of the earliest people to enter the Americas. Among the most famous inhabitants of these northern grasslands was the woolly mammoth. Their bodies were covered with long, shaggy hair that protected a dense, insulating undercoat hidden beneath. Thick layers of fat beneath the skin helped conserve body heat, while their ears were much smaller than those of African elephants, reducing the amount of heat lost to the surrounding air. Even their tails were shorter, another adaptation that reduced exposure to freezing temperatures. Every aspect of their bodies reflected countless generations of natural selection acting upon animals living in one of the harshest environments on Earth. The great curved tusks of woolly mammoths could grow several meters in length and served many purposes throughout their lives. They were used to move snow aside in search of grasses buried beneath the surface, to strip bark from trees, to dig for vegetation frozen within the ground, and perhaps to display strength during encounters between rivals. Their muscular trunks remained just as versatile as those of living elephants, allowing them to gather food with remarkable precision despite the cold conditions. Fossilized stomach contents and preserved plant remains found alongside some mammoths reveal diets consisting mainly of grasses, sedges, flowering plants, and other hardy vegetation that flourished across the steppe. Although the environment appears severe by modern standards, it provided abundant food for animals perfectly adapted to living there. One of the reasons we know so much about woolly mammoths is that several individuals have been discovered remarkably well preserved within the permanently frozen ground of Siberia and northern North America. In these regions, known as permafrost, the soil remains frozen throughout the year, greatly slowing the process of decay. Occasionally, entire mammoths have been recovered with skin, hair, muscles, and even the contents of their stomachs still preserved after tens of thousands of years. These extraordinary discoveries provide scientists with an unparalleled opportunity to study animals that would otherwise be known only from bones. The color of their fur, the structure of their muscles, the plants they last consumed, and even traces of their DNA have all helped researchers build a detailed understanding of their lives. Living alongside the mammoths were many other remarkable mammals equally well adapted to the cold. Woolly rhinoceroses grazed the frozen plains with thick coats protecting them from icy winds. Massive steppe bison traveled in herds across open country, while wild horses continued grazing much as their ancestors had done for millions of years. Musk oxen, reindeer, and saiga antelope occupied different parts of these northern ecosystems, each specializing in particular foods and habitats. Far from being empty wilderness, the mammoth steppe supported an extraordinary abundance of life. Predators followed the herds, scavengers cleaned the landscape, and countless birds nested during the brief northern summers before migrating south as winter returned. The horizon stretched almost endlessly beneath an immense sky, interrupted only by distant herds moving slowly across the plain. Cold winds carried the scent of dry grasses and frozen earth, while the low winter sun cast long shadows across the landscape. During the summer months, wildflowers added unexpected color to the open ground, attracting insects that took advantage of the brief season of warmth. The age of mammals had reached one of its most recognizable moments, with giant herbivores shaping the landscape just as surely as glaciers shaped the land beneath their feet. The Ice Age grasslands were not ruled by herbivores alone. Wherever large herds gathered, predators inevitably followed, and the later Cenozoic became home to some of the most impressive hunters in mammalian history. Yet life for a predator was rarely easy. Every successful hunt demanded enormous amounts of energy, patience, and skill, while many attempts ended in failure. A lion living on the African savanna today succeeds in only a portion of its hunts, and the great predators of the Ice Age almost certainly faced similar challenges. They could not afford to waste energy carelessly. Every chase carried a risk of injury, and even a minor wound could threaten survival in a world without modern medicine or easy sources of food. Among the most famous predators of this time was the saber-toothed cat, often called Smilodon. Despite its popular name, it was not the direct ancestor of any living tiger or lion. Instead, it belonged to a separate branch of the cat family that evolved its own remarkable adaptations. Its body was powerfully built, with broad shoulders, muscular forelimbs, and a comparatively short tail. Rather than relying upon long pursuits across open country, Smilodon appears to have been an ambush hunter, using strength and surprise to overpower large prey before delivering a carefully placed bite with its extraordinary canine teeth. Those famous canine teeth could reach nearly 30 centimeters in length in the largest individuals. At first glance, they appear fragile, yet their shape suggests they were designed for a very specific purpose. Scientists believe Smilodon probably used its strong forelimbs to hold struggling prey while delivering a precise bite to soft areas of the neck. The jaws themselves did not produce the strongest bite of any cat, but they could open to an astonishing angle, allowing the long teeth to be used effectively. This specialized hunting strategy worked successfully for hundreds of thousands of years, demonstrating that these remarkable predators were highly adapted to the environments in which they lived. Although the saber-toothed cat often captures the imagination, it was only one member of a much larger community of predators. Dire wolves traveled across parts of North America in organized packs, probably hunting many of the same large herbivores that attracted Smilodon. Short-faced bears, among the largest bears ever to exist, also wandered these landscapes. Standing upright, some individuals reached heights well above 3 meters. Whether they hunted regularly or relied more heavily upon scavenging remains a subject of scientific discussion, but their impressive size would certainly have made them formidable competitors whenever a large carcass became available. Every successful kill attracted attention, and predators often found themselves competing not only with their intended prey, but also with one another. The herbivores of the mammoth steppe were far from defenseless. Adult mammoths possessed tremendous size and strength, while their long tusks could become powerful weapons if threatened. Herds likely formed protective circles around their young, much as modern elephants do when confronted by danger. Steppe bison relied upon sharp horns and the safety of remaining together in large numbers. Wild horses depended upon speed and vigilance, with many eyes constantly watching for movement across the open plains. Every species developed its own way of reducing risk, creating a delicate balance that remained stable for thousands of years. Predators rarely eliminated healthy populations because their own survival depended upon the continued abundance of the animals they hunted. The Ice Age also supported one of the most extraordinary birds ever known. In parts of South America, enormous flightless birds known as terror birds occupied the role of dominant predators for millions of years. Some species stood nearly 3 meters tall, with long, powerful legs that allowed them to move swiftly across open ground. Their heads carried immense hooked beaks, capable of delivering devastating blows. Unlike the great mammalian predators of the Northern Hemisphere, these birds belong to a lineage that had evolved after the disappearance of the non-avian dinosaurs. In a fascinating way, they demonstrate that large predatory birds briefly occupied ecological roles similar to those once held by much older reptilian hunters. Their reign eventually came to an end as changing climates and the arrival of new mammalian predators altered the balance of South American ecosystems. While fierce hunters certainly existed, much of the daily life on the mammoth steppe remained surprisingly peaceful. For long periods, grazing mammals fed quietly beneath wide skies, traveling steadily across the landscape in search of fresh vegetation. Birds gathered around shallow lakes during the brief northern summers. Insects emerged wherever wildflowers bloomed, and countless smaller mammals carried out their lives beneath the shelter of grasses and shrubs. Even the great predators spent much of their time resting rather than hunting, conserving valuable energy until an opportunity appeared. The Ice Age was not a world of constant conflict. Like every healthy ecosystem, it was filled with long stretches of quiet routine, interrupted only occasionally by moments of intense activity. As scientists continue studying fossil sites from this period, they often discover evidence that many of these animals lived longer and more complex lives than once imagined. Tooth wear reveals how diets changed as individuals aged. Healed fractures show that some animals survived serious injuries, and growth patterns preserved within tusks and bones record seasons of plentiful food, as well as years of hardship. Mammoth tusks, in particular, grow in layers much like the rings of a tree, preserving a detailed record of each animal's life. By examining these layers, researchers can estimate age, periods of stress, migrations, and even changes in diet over time. Every fossil carries a quiet history waiting to be understood. The later Cenozoic had become a world of remarkable contrasts. Great herds wandered beneath immense skies, predators followed ancient migration routes, and life continued adapting to climates that shifted almost imperceptibly from one generation to the next. Yet another group of mammals was quietly following a very different evolutionary path, one that did not depend upon greater size, longer tusks, or sharper teeth. High among the branches of ancient forests, the earliest primates were developing characteristics that would eventually shape a lineage unlike any other in the history of the age of mammals. The first primates did not resemble modern humans. They were agile creatures that spent much of their lives among branches, where keen eyesight, flexible hands, and excellent balance offered valuable advantages. The forest provided food, shelter, and protection, encouraging these mammals to develop abilities that would later become defining characteristics of the entire primate family. Life in the trees demanded a different set of skills than life on the ground. A misplaced step could mean a dangerous fall, so climbing mammals benefited from hands capable of gripping branches securely. Over millions of years, many primates evolved fingers and toes that could grasp with surprising precision. Their nails gradually replaced claws, allowing the sensitive tips of their fingers to detect the texture and shape of whatever they touched. Flexible shoulder joints made climbing easier, while forward-facing eyes improved depth perception, helping them judge the distance between branches before making a leap. These adaptations did not appear all at once. Vision became especially important for animals living high among the trees. Many early mammals relied heavily upon their sense of smell, but primates increasingly depended upon their eyesight. Having both eyes facing forward allowed the brain to combine two slightly different images into a single three-dimensional view of the surrounding world. This ability made it easier to estimate distances accurately while moving through the forest canopy. A branch that seemed safely within reach from one angle might actually be much farther away, and a small error could have serious consequences. Improved depth perception therefore became an important advantage for animals spending much of their lives above the ground. The forests themselves continued providing an extraordinary variety of foods. Fruits, flowers, seeds, leaves, insects, and tree sap all formed part of the diets of different primate species. Seasonal changes encouraged flexibility, with many animals adjusting their feeding habits as certain foods became more or less abundant throughout the year. This varied diet rewarded curiosity and the ability to remember where particular trees produced fruit or when certain flowers bloomed. Over time, the brains of many primates became larger relative to their body size, supporting increasingly complex behaviors. Memory, problem-solving, and social interactions all became more important as these animals adapted to the changing rhythms of forest life. Living in groups also offered important advantages. Many primates benefited from the protection provided by additional eyes watching for predators. While some individuals searched for food, others remained alert for danger approaching through the trees or across the forest floor. Young animals learned by observing older members of the group, gradually mastering the skills needed to survive in a complicated environment. Social bonds strengthened cooperation, reduced conflict within families, and improved the chances that vulnerable offspring would reach adulthood. Although the earliest primates were evolving in the forests, they represented only one small branch of a much larger mammalian family tree. Countless other mammals continued following their own evolutionary paths across deserts, mountains, grasslands, wetlands, and coastlines. The Cenozoic was never shaped by a single successful group. Instead, it was defined by extraordinary diversity, with thousands of species adapting to environments that ranged from tropical rainforests to frozen northern plains. Every ecosystem contributed something unique to the continuing story of life, and every species occupied its own place within the complex web of relationships that connected the natural world. As the millions of years continued passing, Some forests gradually gave way to more open woodlands in parts of Africa. These environments encouraged new challenges for certain primates. Traveling between groups of trees sometimes required crossing exposed areas where predators could more easily spot them. Individuals capable of moving efficiently across the ground gained advantages under these conditions, although climbing remained an essential part of daily life. The gradual expansion of these mixed habitats would eventually influence one of the most significant evolutionary developments in mammalian history. It is important to remember that none of the early primates were becoming human. They were simply adapting to the environments around them, just as horses adapted to grasslands and whales adapted to life in the oceans. Humans and the other living apes share common ancestors that lived millions of years ago, but evolution does not progress along a straight line. Many branches developed from those ancient ancestors, with some leading to modern monkeys, others to apes, and countless others ending in extinction. The fossil record reveals a richly branching tree rather than a ladder, with every surviving species representing just one of many possible outcomes shaped by changing environments over immense spans of time. By the later Cenozoic, the foundations of the modern natural world had largely been established. Yet the Earth remained a planet in motion. Glaciers continued advancing and retreating. Sea levels rose and fell. Continents drifted by almost imperceptible amounts, and climates shifted through repeating cycles of warming and cooling. Against this ever-changing backdrop, one particular lineage of African primates would eventually begin walking upright across the landscape, carrying with it the earliest beginnings of a journey that would one day spread across every continent on Earth. Over the past several million years, those upright walking primates gradually spread into a variety of environments, each presenting new challenges that encouraged further adaptation. Some landscapes were rich with rivers and woodlands, while others consisted of broad grasslands stretching far beyond the horizon. Living in these changing habitats required flexibility rather than specialization. Food sources varied from season to season. Weather patterns shifted over long periods, and animals capable of adjusting to these conditions often enjoyed the greatest success. The ability to solve problems, cooperate with others, and remember the location of reliable food and water gradually became increasingly valuable. These qualities, combined with millions of years of evolution, slowly shaped the ancestors of modern humans. One of the defining characteristics of these early human ancestors was the gradual development of upright walking, a form of movement known as bipedalism. Walking upon two legs freed the hands for carrying food, gathering useful objects, and eventually making increasingly sophisticated tools. It also raised the body higher above the surrounding grasses, making it easier to watch for predators or locate distant members of the group. Scientists continue studying exactly why upright walking first evolved, and it is likely that several advantages worked together over many generations. Whatever the precise combination of reasons, bipedalism became one of the most distinctive features separating our lineage from that of other living primates. As brains gradually increased in size, early humans became capable of increasingly complex behavior. Larger brains required considerable amounts of energy, making reliable food sources especially important. Cooperation within groups helped improve the chances of finding enough nourishment while also providing greater protection from predators. Individuals shared information, learned from one another, and gradually passed useful knowledge between generations. Unlike instincts, which are inherited genetically, learned behavior could change much more rapidly. A successful hunting technique, a safer route across the landscape, or the knowledge of edible plants could all be taught to younger members of the group, allowing experience to accumulate over time. The earliest stone tools appeared more than 3 million years ago and represent an important milestone in human evolution. These tools were remarkably simple compared with those that would come much later, yet they demonstrate careful planning and purposeful action. A suitable stone had to be selected, struck at the correct angle, and shaped into a useful cutting edge. Sharp flakes could be used to process meat, cut plants, or scrape hides. Although many other animals use objects in simple ways, the deliberate manufacture of stone tools marked the beginning of a technological tradition that would continue developing throughout the remainder of the Cenozoic. Even these earliest tools reveal an ability to modify the environment rather than simply respond to it. For hundreds of thousands of years, early humans lived alongside many of the remarkable mammals that had evolved during the Cenozoic. Humans were not yet the dominant force they would eventually become. They shared the world with a rich variety of large mammals, each perfectly adapted to its own way of life. Survival depended upon careful observation, cooperation, and an intimate understanding of the surrounding environment. Rivers provided fresh water, forests supplied food and shelter, and changing seasons influenced the movements of both people and animals. Some groups learned to thrive in tropical forests where food remained plentiful throughout much of the year. Others occupied dry grasslands, rugged mountain valleys, or the cold northern regions influenced by advancing glaciers. Clothing made from animal hides provided protection against freezing temperatures, while carefully controlled fire offered warmth, light, and a place where families could gather after sunset. Fire also made food easier to digest and helped keep dangerous predators at a distance. These practical skills allowed humans to occupy environments that would otherwise have been extremely difficult to survive. The repeated advance and retreat of the ice ages continued influencing human history, just as they influenced every other living species. During colder periods, lower sea levels exposed land bridges connecting regions that are now separated by water. Their journeys unfolded over thousands of years, guided not by maps, but by the availability of food, fresh water, and safe places to live. Although humans would eventually reshape the natural world in profound ways, it is important to remember how small a portion of the Cenozoic our own species occupies. The era began about 66 million years ago, while modern humans have existed for only a tiny fraction of that immense span of time. If the entire Cenozoic were compressed into a single calendar year, humans would appear only during the final moments of the final day. For almost all of the age of mammals, the Earth belonged to countless other species whose lives unfolded long before our own ancestors began leaving footprints upon the landscape. This perspective offers a gentle reminder of just how ancient and enduring the natural world truly is. Today we remain part of the same Cenozoic era that began after the extinction of the non-avian dinosaurs. Modern elephants still carry echoes of their ancient proboscidean ancestors. Whales continue swimming through the oceans after one of evolution's most extraordinary transformations from land to sea. Horses still run across open landscapes shaped by the spread of grasslands, while primates continue inhabiting forests that resemble those of their distant ancestors. The age of mammals has never truly ended. The Cenozoic is sometimes described as the age of mammals, but it could just as easily be called the age of transformation. Throughout these 66 million years, almost every part of the Earth changed in some way. At the same time, mammals evolved from small creatures living beneath the feet of dinosaurs into the dominant large animals across much of the planet. None of these changes happened suddenly. The landscapes we recognize today are the result of this immense history. The Himalayas continue rising because the Indian continent still presses slowly against Asia, just as it has for tens of millions of years. Rivers continue wearing away mountains grain by grain, carrying tiny fragments of rock towards the sea. Even coastlines are constantly changing as waves reshape beaches and rivers deposit fresh sediments along their banks. Many of the animals that share the world with us today still carry clear traces of their ancient ancestry. A horse galloping effortlessly across an open field reflects countless generations of adaptation to expanding grasslands. Every whale rising to breathe at the ocean's surface tells the story of ancestors that once walked upon four legs beside rivers and coastal marshes. Even the smallest bat leaving its daytime shelter at dusk belongs to a lineage that discovered the remarkable ability to fly while mammals were continuing to diversify across the Cenozoic. Every living mammal is part of a family history far older than any civilization. Scientists continue uncovering new fossils that deepen our understanding of this remarkable era. Every year, discoveries are made in deserts, mountain ranges, ancient lakebeds, and exposed cliffs around the world. Sometimes researchers recover an entirely new species, unlike anything previously known. At other times, a single tooth, a fragment of jaw, or a series of footprints provides enough evidence to answer questions that have puzzled scientists for decades. Modern technology has transformed the study of these fossils. Powerful imaging systems allow researchers to examine the delicate internal structure of bones without damaging them, while chemical analysis reveals information about ancient diets, climates, and migration patterns. In some exceptional cases, fragments of ancient proteins and genetic material have survived long enough to offer additional clues about relationships between extinct species and the animals living today. One of the greatest strengths of science is that every new discovery has the potential to improve what we already know. The picture we have of the Cenozoic today is far richer than it was only a few decades ago, and future discoveries will almost certainly continue refining our understanding. This does not mean previous scientists were wrong. In many ways, the study of the Cenozoic mirrors the evolution it seeks to explain. Knowledge itself grows little by little, with thousands of small discoveries gradually creating a much clearer view of the distant past. Forests become grasslands, glaciers advance and retreat, rivers alter their courses, and species evolve alongside the environments they inhabit. Nothing remains exactly the same forever, yet life repeatedly demonstrates an extraordinary ability to adapt. Yet over millions of years, life not only returned but flourished in astonishing new forms. Giant mammals crossed frozen plains, whales became masters of the oceans, primates explored the forest canopy, and eventually humans looked back through time to understand how all of it came to be. As evening settles and the world around you grows quieter, it is comforting to remember that the planet beneath us has always been moving at its own gentle pace. The continents continue drifting by tiny amounts each year. Mountains continue rising while others slowly wear away beneath wind, rain, and flowing rivers. These processes ask for nothing from us. They simply continue, just as they have for millions upon millions of years, forming the steady rhythm of a living planet. The Cenozoic has never been a tale of sudden endings or permanent destinations. From the first small mammals exploring recovering forests after the disappearance of the dinosaurs, to the mammoths roaming windswept northern grasslands, to the elephants, whales, horses, bats, and people of today, each has occupied only a brief moment within an era that continues even now. As you settle more deeply into rest, it is pleasant to imagine that somewhere beyond the quiet of the present, forests are still growing, mountains are still rising, oceans are still moving, and the great age of mammals continues its slow and patient journey into the future. We often divide history into centuries, kingdoms, or civilizations because those timescales feel immense to us. Geologists, however, measure time differently. They observe the slow movement of continents, the rise of mountain ranges, and the evolution of entire groups of living creatures across millions of years. From that perspective, the Cenozoic is not a distant era sealed away in the past. It is the present. Every sunrise, every passing season, and every generation born today belongs to the continuing age of mammals. That thought has a quiet way of changing how we see the familiar world around us. A walk through a woodland becomes more than a pleasant afternoon beneath the trees. It becomes a brief visit to landscapes shaped by countless generations of life adapting to changing climates. Watching birds rise from a meadow or deer step carefully through the undergrowth connects us with evolutionary journeys stretching back millions of years. Even the smallest mammal disappearing beneath a hedge carries within it an unbroken history that reaches to the earliest days of the Cenozoic. Every living species represents another branch of an ancient family tree whose roots extend deep into geological time. The oceans also continue carrying echoes of that long history. Modern whales still undertake extraordinary migrations that span thousands of kilometers each year, traveling between feeding grounds and warmer waters where their young are born. Dolphins communicate through an intricate collection of whistles and clicks while navigating with remarkable precision beneath the waves. Seals rest upon rocky shores before returning to the sea, and sea otters float peacefully among forests of kelp. None of these marine mammals would exist had a small group of land-dwelling ancestors not gradually adapted to life beside ancient rivers and coastlines tens of millions of years ago. Across the grasslands, the descendants of ancient grazing mammals still move in herds, much as their ancestors once did. Horses continue running across open country with the same efficient stride, shaped by millions of years of natural selection. Antelope, bison, deer, and countless other herbivores depend upon landscapes where grasses remain abundant, carrying forward ecological relationships first established when grasslands spread across the Cenozoic world. Predators still follow those herds, maintaining the delicate balance that has existed for countless generations. Although individual species have changed through time, the great rhythms of nature remain wonderfully familiar. The forests continue telling their own quiet story, Each towering tree began as a tiny seed, growing gradually year after year until it became part of a living community, supporting birds, insects, fungi, mammals, and countless microscopic organisms hidden within the soil. Fallen leaves nourish the next generation of plants, streams carry nutrients through the landscape, and sunlight filters gently through the canopy, just as it did in forests long before humans appeared. The details have changed, yet the fundamental patterns remain. Perhaps one of the greatest gifts offered by studying the Cenozoic is a sense of perspective. Mountains do not hurry as they rise, rivers do not rush as they shape their valleys, and forests do not compete to reach maturity. Every process unfolds according to its own natural rhythm. A slight shift in climate, a tiny variation within a population, or a continent drifting only a few centimeters each year can eventually reshape the entire world when given enough time. As you become more relaxed, it is pleasant to imagine those immense stretches of time unfolding almost silently. Picture warm forests where tiny mammals searched beneath broad leaves while unfamiliar birds called from the branches overhead. Imagine ancient rivers winding through landscapes untouched by people, carrying clear water towards distant seas. Every one of those moments belongs to the same continuous era that surrounds us today, connected across millions of years by the steady passage of time. The Cenozoic has often been called the age of mammals, yet it is equally the age of resilience. After one of the greatest extinction events in Earth's history, life recovered with extraordinary patience and creativity. Rather than remaining fixed, the living world demonstrated an endless capacity to adapt, reminding us that change has always been woven into the history of our planet. And so, as this peaceful journey through deep time comes gently to rest, the Earth continues turning beneath the stars, exactly as it did when the first forests recovered after the dinosaurs, when whales first entered the sea, when mammoths crossed the northern plains, and when our earliest ancestors looked across the African landscape. The age of mammals has never truly ended. It continues quietly around us, with every changing season, every growing forest, every migrating whale, and every new generation of life. Looking around us today, it is easy to imagine that the natural world has always appeared this way. Yet the fossil record tells a very different story. Continents have traveled thousands of kilometers, oceans have opened and narrowed, climates have shifted repeatedly, and entire groups of animals have appeared, flourished, and eventually disappeared. The Earth has never stood still, even though its changes are usually measured on timescales far beyond a human lifetime. Many of the rocks beneath our feet preserve silent evidence of this extraordinary history. Layers of sandstone were once ancient deserts where winds carried fine grains across endless dunes. Thick beds of limestone formed beneath warm tropical seas, filled with marine life that disappeared millions of years ago. To a geologist, every cliff face is a record of changing environments, each layer preserving a small part of the Earth's long memory. The Cenozoic occupies only the most recent portion of that record, yet it contains the entire rise of the modern living world. Even the animals we share the planet with continue adapting in subtle ways. Evolution did not stop when mammoths disappeared or when humans spread across the continents. Every generation introduces small variations, just as it always has. Most of those differences are almost impossible to notice, but over enough time they accumulate just as they did throughout the age of mammals. Birds adjust to changing habitats, mammals expand into new environments, plants spread into regions where conditions become favorable, and countless microscopic organisms evolve at a pace far quicker than larger animals. Life remains every bit as dynamic today as it was millions of years ago, continuing the same natural processes that began long before humans appeared. The remarkable thing about deep time is that it encourages patience. During our daily lives, we often measure progress in hours, weeks, or years. Geological time asks us to think differently. Rivers carve valleys one grain of sand at a time. Coral reefs grow through the work of countless tiny animals, building delicate skeletons over thousands of generations. Mountains rise only a few millimeters in a year, yet eventually tower above the surrounding landscape. If someone had stood beside those first small mammals shortly after the extinction of the non-avian dinosaurs, nothing about them would have suggested the future that awaited their descendants. There was no indication that one lineage would eventually become the largest animal ever to inhabit the oceans. Nothing hinted that another would develop towering tusks and trunks capable of astonishing precision. No one could have predicted graceful horses racing across open plains, bats navigating through complete darkness, or primates developing the ability to understand their own origins. Yet every one of those possibilities already existed, quietly hidden within populations of ordinary animals, simply living from one day to the next. Evolution revealed those possibilities only because it was given the vast gift of time. It demonstrates that the familiar landscapes surrounding us today are the product of an unimaginably long history. Every living mammal carries traces of ancestors that survived changing climates, shifting continents, and countless environmental challenges. Every forest has inherited soils shaped by ancient rivers, glaciers, and long-vanished ecosystems. Even the air we breathe has been influenced by millions of years of interactions between plants, oceans, volcanoes, and the atmosphere itself. Nothing exists in isolation. So as you settle more deeply into rest, it is comforting to imagine the earth continuing its quiet work beneath the evening sky. Somewhere, rivers are gently flowing towards the sea. Whales are crossing vast oceans that have existed in changing forms throughout the Cenozoic. Elephants are walking ancient migration routes first established by distant ancestors millions of years ago. The world has always been changing, yet its changes unfold with extraordinary patience. The age of mammals is still with us. It surrounds every landscape, every coastline, every forest path, and every open plain. It lives in the quiet rhythm of nature, in the steady passage of the seasons, and in every living creature that carries within it a history stretching back through millions upon millions of years. And while the world continues its slow journey into the future, you can simply rest, knowing that the same patient earth, which nurtured tiny forest mammals, giant ground sloths, saber-toothed cats, mammoths, whales, elephants, and countless other remarkable creatures, continues turning gently beneath the stars tonight, just as it has throughout the long and extraordinary age of mammals. A tiny field mouse searching for seeds beneath a hedge and a blue whale traveling through the open ocean appear to have almost nothing in common, yet both belong to a family whose earliest members quietly survived the extinction that ended the age of the non-avian dinosaurs. From those humble beginnings came an astonishing variety of forms. Some mammals learned to glide through the night sky before true powered flight evolved in bats. Others became expert swimmers, fearless climbers, powerful diggers, or swift runners, capable of crossing vast grasslands with effortless grace. At one end of the scale are tiny shrews that weigh little more than a coin and must eat almost constantly to fuel their rapid metabolism. At the other are blue whales, whose hearts alone can weigh as much as a small motor car. Between those extremes lies an incredible variety of life, including bats no larger than a person's thumb, elephants standing several meters tall, dolphins navigating the oceans with remarkable intelligence, and mountain goats climbing cliffs that appear almost impossible to scale. Every one of these animals represents a successful solution to the challenges of survival, each carefully shaped by millions of years of natural selection. The Cenozoic also demonstrates that success in nature can take many different forms. Some mammals became highly specialized, adapting so closely to particular environments that they thrived only under specific conditions. Others remained more adaptable, able to survive across a wide range of habitats and climates. Neither strategy is inherently better than the other. A highly specialized animal may flourish for millions of years, while its preferred environment remains stable, whereas a more flexible species may cope more easily when conditions begin to change. Throughout the Cenozoic, both approaches proved successful at different times, illustrating that evolution does not favor perfection, but rather whatever works best under the circumstances of the moment. The same principle applies to entire ecosystems. Remove one important part of that community, and countless other relationships are affected in ways that may not be immediately obvious. Large herbivores shape vegetation through grazing and browsing. Predators help maintain healthy populations of prey. Insects pollinate flowering plants, while fungi recycle fallen wood and leaves into nutrients that nourish new growth. The Cenozoic reveals not only the evolution of individual species, but also the evolution of entire living communities. Modern conservation efforts often draw inspiration from this deep history. By studying ancient climates, fossil ecosystems, and previous periods of environmental change, scientists gain valuable insight into how species responded to changing conditions in the past. Fossils reveal which animals adapted successfully, which habitats expanded or contracted, and how entire ecosystems recovered following periods of disturbance. Although the modern world presents challenges unlike those of earlier ages, the geological record provides an invaluable perspective. Another enduring lesson from the Cenozoic is the importance of patience in scientific discovery. Many of the fossils that transformed our understanding of mammal evolution were found only after decades of careful searching. Some rested unnoticed within exposed rocks until changing weather revealed a fragment of bone at the surface. Others emerged during road construction, mining operations, or routine geological surveys. A single tooth discovered in the correct layer of rock can inspire years of research, eventually leading to entirely new interpretations of evolutionary history. Every discovery depends upon the work of countless people, from field researchers carefully excavating fossils to laboratory specialists studying microscopic details preserved within ancient remains. For thousands of years, people admired mountains, rivers, forests, and strange fossil bones without fully understanding their immense age. Likewise, Paleontology has gradually uncovered the long succession of mammals that lived before us, revealing a history extending tens of millions of years into the past. Each generation of scientists has added another piece to that understanding, allowing us to appreciate the age of mammals with ever greater clarity and wonder. As night grows quieter and your thoughts begin to slow, it is comforting to remember that the world outside continues following the same gentle rhythms that have guided life throughout the Cenozoic. The wind moves softly through forests whose distant ancestors shaded small mammals millions of years ago. Whales rise to breathe beneath the stars. Elephants guide their families across familiar landscapes, and countless smaller mammals begin their nightly search for food beneath the cover of darkness. The age of mammals is not merely a subject to study. Although the Cenozoic continues today, many of its most famous inhabitants now exist only as fossils preserved within ancient rocks, frozen ground, or layers of sediment laid down long ago. A mammoth tusk emerging from melting permafrost, the footprint of a giant ground sloth preserved in ancient mud, or the delicate skeleton of an early whale resting within limestone, all allow us to glimpse moments from lives lived thousands or even millions of years before our own. These discoveries are often separated by vast distances and spans of time, yet together they help reveal the remarkable continuity of the age of mammals. One of the most surprising mammals of the later Cenozoic was the giant ground sloth. Unlike the small tree sloths that move slowly through the forests of Central and South America today, these enormous relatives spent nearly all of their lives on the ground. Some species stood well over 3 meters tall when rising onto their hind legs, making them comparable in height to modern elephants. Their long curved claws were not designed for hunting, but for pulling branches closer, while feeding or digging for roots and other vegetation. Despite their impressive size, evidence suggests they were gentle herbivores, browsing quietly through forests and open woodlands, where they fed upon leaves, shoots, and shrubs. The skeleton of a giant ground sloth reveals an animal built for strength rather than speed. Powerful hind limbs supported much of its weight, while a thick, muscular tail acted almost like a third leg when the animal stood upright to reach higher branches. This sturdy posture allowed it to feed on vegetation unavailable to many other herbivores sharing the same environment. Their movements were almost certainly slow and deliberate, conserving energy while relying upon their enormous size for protection. Few predators would willingly challenge a healthy adult capable of defending itself with heavy forelimbs armed with formidable claws. Growing to more than 2 meters in length, it weighed as much as a modern black bear. Despite its size, it probably lived in much the same environments as today's beavers, favoring lakes, rivers, and wetlands rich in aquatic vegetation. Unlike modern beavers, however, scientists believe giant beavers were less specialized at cutting down large trees. Their broad incisor teeth appear better suited for feeding upon soft water plants rather than felling timber. Even so, they remind us that familiar groups of animals often included members that reached sizes almost unimaginable today. The reasons were often complex and differed from one species to another. In other places, the arrival and expansion of human populations introduced new pressures through hunting and changes to the landscape. Scientists continue studying these events carefully because the evidence suggests that no single explanation applies everywhere. Instead, many extinctions likely resulted from several factors acting together over long periods of time. Even after those great Ice Age mammals disappeared, the ecosystems they once inhabited continued evolving. Forests expanded into areas that had previously been open steppe, while rivers altered their courses as glaciers melted and released enormous quantities of water. Plants adapted to warmer conditions spread into newly available habitats, followed by animals capable of thriving within those changing environments. Nature once again demonstrated its remarkable resilience. The disappearance of one group created opportunities for others, continuing the same pattern of renewal that had shaped the Cenozoic since its very beginning after the extinction of the non-avian dinosaurs. The grasses beneath our feet, the whales crossing the oceans, the elephants walking across African plains, and the bats emerging quietly at dusk, all belong to lineages whose roots extend deep into this era. They are not isolated wonders, but living parts of a shared evolutionary heritage that has unfolded across 66 million years. Understanding those connections helps us appreciate that every species carries within it a history far older than any human civilization. The more we learn about the Cenozoic, the more we come to appreciate that the modern world is the product of extraordinary patience. Every mountain valley, every coastline, every woodland, and every meadow has been shaped through countless generations of gradual change. Life did not rush towards its present form, and neither did the earth itself. Instead, both evolved together, influencing one another across an immense span of time that continues to this very day. As you settle more deeply into relaxation, imagine the earth continuing its journey beneath familiar stars. Forests grow one leaf at a time, rivers carry grains of sand towards the sea, whales glide through dark oceans, and elephants follow paths traveled by generations before them. These rhythms connect the present with the earliest days of the age of mammals. The Cenozoic has unfolded for 66 million years, and tonight it continues, one peaceful moment at a time. As our journey through the Cenozoic draws to a close, the ancient world remains connected to the one we know today. Mammals that explored a recovering planet eventually produced elephants, whales, horses, bats, primates, and every other mammal now living. Rivers kept carving valleys, mountains rose towards the sky, and oceans carried warmth around the globe. Through gradual change, the familiar world emerged from the distant past. Every landscape grows from what came before it, and every living species inherits a legacy shaped by countless ancestors. Forests nourish the soil, rivers carry sediment towards new coastlines, and plants and animals remain joined through food, shelter, and the spreading of seeds. Throughout the age of mammals, these relationships have sustained a living world of balance and resilience. Against the span of 66 million years, the Earth seems to breathe with a slower rhythm. Continents drift almost unnoticed. Mountains rise too gradually for any creature to watch them grow, and rivers shape valleys grain by grain. Great transformations can begin with movements too small to notice. Nature has never needed to hurry. The horse grazing in a field carries the history of small forest-dwelling ancestors that walked on several toes beneath warm leaves. The whale rising to breathe reflects evolution's long movement from land to sea. The elephant guiding food with its trunk belongs to a lineage that survived changing climates and shifting continents. Even the smallest mammal beneath the leaves has roots reaching towards the beginning of this era. As evening grows quieter and sleep draws closer, imagine the earth continuing through time. The tide rises along a distant shore, rain falls through a forest, and herds cross open grasslands. Birds settle into their nests, while whales move through deep oceans beneath the moon. These peaceful rhythms connect the distant past with the present. Long before people measured time with clocks or calendars, seasons came and went, rivers flowed towards the sea, and mountains changed beneath wind, rain, and ice. The Cenozoic has followed that steady rhythm for 66 million years. While we rest, forests grow, oceans circulate, stars cross the night sky, and the living world carries its ancient legacy forward. Thank you for joining me on this peaceful journey through the age of mammals. I hope you enjoyed exploring the history of the Cenozoic and discovering how the modern world came to be. Until our next peaceful journey, rest well and sleep deeply.